Hello and welcome to IB Mathematics. So today we are continuing with our previous year question series and we are on the question number 6. Consider the equation ax square plus bx plus c equals to 0 where a is not equal to 0. Given that the root of these equations are x equals to sine theta and x equals to cos theta, then show that b square equals to a square plus 2ac. Now we know that sum of roots of quadratic equation is equals to minus b by a, and product of roots is equals to c by a. Sum of roots. So the roots are sine theta and cos theta. It means sine theta plus cos theta is equals to minus b by a, and product will be sine theta multiplied by cos theta is equals to c by a. Now we need to calculate b square. So to take the b square, we have to square this side. So squaring both sides, so it will be sine theta plus cosine theta whole squared equals to minus b by a whole squared. Now it's sine squared theta plus cos squared theta plus twice sine theta cos theta equals to b square over a square. Now we know that sine square theta plus cos square theta equals to 1, and the value of sine theta and cos theta is c by a. So I just simply put the value of sine theta into cos theta. Now we will simplify it. So it will be a plus 2c over a equals to b square over a square. Now a will cancel out. So it's a square plus 2ac equals to b square. I just took this a to the other side. So we just showed this b square equals to a square plus 2ac. Now the next question, consider the complex number z1 is equals to cos 11 pi by 12 plus iota sin 11 pi by 12, and z2 as cos 11 pi by 6 plus iota sin pi by 6. So we need to find z1 over z2. So in this we know that using de Moivre's theorems. Okay, the theorem is de Moivre's theorem. So for z1 over z2, just we need to, okay, I'll just write it. So if z1 is r times cos theta plus iota sin theta, and z2 is r cos alpha plus iota sin alpha. So z1 over z2 is r times cos theta minus alpha plus iota sin theta minus alpha. So we use the same theorem here. So z1 over z2 will be cos 11 pi by 12 minus pi by 6 plus iota sin 11 pi by 12 minus pi by 6. We'll simplify this. So it will be cos 3 pi by 4 plus iota sin 3 pi by 4. Now we need to find z2 over z1. So for z2 over z1, we need to subtract pi by 6 minus 11 pi by 6 iota sin pi by 6 minus 11 pi by 6. So this will be cos minus 3 pi by 4 plus iota sin minus 3 pi by 4. So it will be cos 3 pi by 4 only. Minus, or we can directly write it as this, and minus iota sin 3 pi by 4. Okay, now we have this thing. We can just find the value. So cos 3 pi by 4 is 1 over root 2 plus iota sin is minus 1 over root 2 and 1 over root 2. And in this, it's minus 1 over root 2 and it's again minus 1 over root 2 iota. So these are the value of z1 over z2 over z1 and z1 over z2. Now we have three coordinates: 0, it's the origin, and z1 over z2, z2 over z1, represented by the 3 points O, A, B respectively on the diagram page. Determine the area of the triangle AOB. Okay, so we plot these points on the graph. So this is my origin 0, 0. My z1 over z2 will be here. It's minus 1 by root 2, comma 1 by root 2, and this will be my z2 over z1, which is minus 1 by root 2, comma minus 1 by root 2. So we need to find the area of this triangle. So we can directly see this, that this is 45 degree and this is also 45 degree. So this whole is 90 degree, and we can use the area of triangle formula: half base into height. So my base will be this length and height will be this length, and this length is r. And what is my r? So here r is 1. So I just need to put my base as 1 and height as 1. The area will be half square unit. Yeah, or we can say unit square. Now, question number 8. We have to show that sin x multiplied by tan x over 1 minus cos x is equal to 1 plus 1 over cos x. Okay, so in this we can change tan x as sin x over cos x whole divided by 1 minus cos x. So it will be sin square x over cos x whole upon 1 minus cos x over 1. So if we simplify it, so it will be like sin square x over cos x into 1 minus cos x. We can directly come to this step also. Okay, so we can write sin square x as 1 minus cos square x over cos x minus 1 minus cos x, and 1 can be written as 1 square. So we can use the formula property a square minus b square property, which is a minus b multiplied by a plus b. So it will be 1 minus cos x multiplied by 1 plus cos x over cos x 1 minus cos x. We can simply cut this. So we're left with 1 plus cos x over cos x. We will split the two parts. So 1 over cos x plus cos x over cos x will be 1. So we just showed this. Now we have to determine the range of this function. It means whether we can find the range of this function or we can use this function also. It means we have to find the range of this function when this function has no solution. Okay, so we'll take this equals to k, and the value of k is 1 over cos x equals to k minus 1. Just reciprocate it, so it will be 1 over k minus 1. So where this cos x will give the no solution. So cos x when is less than minus 1 and when cos x is greater than 1. So I'll just take this cos x to be replaced with 1 over 1 minus this minus 1 and just reciprocate it, and when we reciprocate, the sign of inequality will change and the answer will be k should be greater than 0, and here 1 over k minus 1 will be this, again reciprocal 1, sign of inequality will change, k should be less than 2. It means whenever k is between 0 and 2 will be my answer. Now in the question number 9, by using the substitution x equals to 10u, find the value of the integration this. So we need to substitute x as 10u. So we need to substitute dx also. So I'll just find dx. So derivating both sides. So x will be dx and 10u will be sec square u du. And we need to change the limit. So when x is 0, u will be 0. When x is 1, u will be pi by 4. We need to just put this thing in x. So I'll show you also. When x is 0, is tan u equals to 0, so u must be 0. When x is 1, so tan u equals to 1, u should be pi by 4. Now, so the limit will be 0 to pi by 4. It's x square, yeah, it's x square, so tan square u over 1 plus tan square u bracket whole cube and the value of dx is sec square u du. Now what is 1 plus tan square u? It's cos square u, so we can substitute it. So it's sec square u whole cube du, 0 to pi by 4. Now we can cut 1, so it will be tan square u over sec 4u du, 0 to pi by 4. Now tan square u will be sin square u over cos square u, and this will be cos 4 times 4u du. Because it will be 2, so I'm left with 0 to pi by 4 sin square u into cos square u du. And just multiplied 4 and divided by 4, so it will be this. I'll just take square common, so 2 sin u cos u whole square du. The limit will be same. Now 2 sin u cos u will be sin 2u. This is a property I'm using directly, and the square is this, so it's sin square 2u du. Now we'll use one more property, which is cos 2x. We can use cos 2 theta equals to 1 minus 2 sin square theta. So it's u, so we can write it like this: cos 4u equals to 1 minus 2 sin square 2u. So I'll just replace it. So the value of sin square 2u is 1 minus cos 4u over 2. So we'll just directly put the values: 1 by 8, 0 to pi by 4, 1 by 2 minus 1 minus cos 4u du. I just multiplied half with this 4, so it's 1 by 8. Now I just integrate this. So the integration of 1 is u, and the integration of cos 4u is sin 4u over 4, and the limit is 0 to pi by 4, and 1 by 8 is outside this. Okay, now we just put the limit. So for I'll put pi by 4, 1 by 8, pi by 4 minus sin pi by 4 is sin pi, and sin pi is 0, so it's 0 only. And now I'll put 0, so minus sign 0 minus of 0, because sin 0 is 0. Now I'll just simplify it, so it will be pi by 4 only, and pi by 4 multiplied with 1 by 8, so it's pi by 32. Pi by 32 will be my final answer. Okay, so we have completed till 9, and section B will start in the next portion. So thank you.